And I just wanted to go through a brief timeline of my experience with GraphQL that brings me to today, the talk that I'm going to be giving. So in 2015, GraphQL JS came out, and immediately it came out, and I was excited about it, and I was like, I'm going to start using this with projects in production. And so I pulled this code snippet out of the first project that I worked with GraphQL, and you can see it's using GraphQL JS, the reference implementation, and it defines a GraphQL object type with sort of fields that you would expect to see if you're modeling a location, a storefront location for like an e-commerce app. And it's a little verbose, but it was sort of worth it for the benefits that you get on the client side. And so, as you'd see, this then generates the SDL that we're familiar with. That's sort of the common language between all the server implementations, where you have your location, it implements an interface, it has all these fields. These fields have types, and it's pretty simple to see how this type exists on the server, and you have all the static benefits that come with that. So then later on in 2015, actually not too long after the reference implementation came out, there was a project called graph.ql. And graph.ql, I was looking up to see if my timeline was correct here, but this was actually the original SDL first approach, this SDL first library. And the first time I saw this, I was like, wow, this is really incredible, because you can start out with this more concise syntax and then take that and sort of just map it to the resolvers without having to do all the imports. You could see that like, this was my reaction when I saw this. I was like, this is so much simpler. And when you compare it to the first GraphQL object type, you can see, maybe not here, but the number of lines of code is significantly less, and even the interface, the fact that you don't have to import it from another place, you can just kind of know where the data is being fetched from, and all of the implementation details of what types you have to import, that's all just kind of goes away. So it seemed way simpler. And then from that, GraphQL tools, I think, came out and sort of robustified a lot of these conventions and came out with sort of the patterns that we know today in the JavaScript development ecosystem, which have been really great. And from there, I started at a company primarily as a front-end engineer, but I noticed that they had a lot of the problems that GraphQL sets out to solve with overfetching data and having API endpoints that are like very specific to the use case, and sort of our own version of a REST endpoint with query params that sort of conditionally fetch data, and it was kind of a mess. And I was like, well, we could really benefit from GraphQL from what I've seen so far, so why don't we adopt this in the company? But the issue was that it was a Python shop, and I went and then looked to see what the available landscape was for that, and came across the library Graphene, which is an excellent library for working with GraphQL in Python. But if you see this, the object type is not SDL first. It's sort of, you're defining it as a native Python object, and then you have a resolve function, and the convention there is to prefix it with resolve underscore, and then the name of the field that you're resolving. But I was like, oh no, like this library doesn't do SDL first. But there was no way I was going to change the development practices of an entire company based on my pitch that this GraphQL thing is the answer to all the problems. So I was like, well, let's see if we can just work with Graphene. And a few months passed, and figured out how the development workflow worked, and how Python metaprogramming works. I hadn't used it too much before then, and sort of how we could reuse code from existing models to generate these more efficiently, and the fact that it was really familiar to be programming in your native language and building up these constructs to generate the SDL. And my takeaway was that this scaled really well to multiple teams. And I just pulled some stats from the SDL that was at the company that I was working on, and it wasn't like a toy application. It wasn't the scale of anything super big, but there were a couple hundred object types, a couple thousand fields, and I think it was roughly 18 developers across a couple different teams developing on the same schema at once. And just for comparison, I think recently pulled the GitHub public API, and I think it was about comparable in size and scope. So my takeaway there was like, there's a lot of value in doing it this way. In 2018 then, I was working on a project that used GraphQL Ruby, more so on the read side, but also realized that they're doing it Codefirst, and this is what GitHub and Shopify are using, and you can see that it's a native Ruby class that defines the fields as properties, and it's not developing the SDL first. After that, I went back to GraphQL tools and started playing around with TypeScript, like auto type generation, with GraphQL code generator, which is really excellent. And it felt familiar because it's what I was doing prior to all of that, but it kind of felt backwards at that point. That it was sort of taking the wrong approach, or that there was something missing. And as I mentioned, GraphQL code generator, I recommend checking it out. You can build up a lot of really cool, really useful types for your front end or for different clients that are consumers based on the schema. So there was a GraphQL meetup in New York City that I attended where Mark, who will be speaking later from GitHub, was asked a question by someone in the audience about how they manage the schema internally. And it was a question about SDL, and he was like, I'm not really sure because SDL first seems very unique to the JavaScript community. And that kind of is when it clicked with me. It was like, well, it feels like we're really missing out on something. And we have the reference implementation, the GraphQL JS, which is sort of the official canonical, when a new feature gets developed, it's prototyped in that first. But it sort of stopped there, and we don't have anything sort of higher level on that. And after doing a little more reading on the topic, I came across this post, and I think it was the namespaces issue in the GraphQL spec, where Lee mentioned that the SDL was not originally intended to be a human-written document, and that there were plenty of design decisions that favor readability over writability. And so I thought, maybe we're doing it wrong, or maybe not wrong, but we could be doing it differently. So the idea was, what might a better code-first, more higher-level code-first approach look like? And this brings me to the library I'll be talking about today, GraphQL Nexus, which the goal is to build an improved experience for building code-first schemas in JavaScript and TypeScript. So a few things I'll be talking about. Why not SDL first? A little bit more on GraphQL Nexus, some related tooling that does Codefirst in the JavaScript, TypeScript ecosystem, and how SDL is still super useful. So why not SDL first? And there's a couple points. The first one that I think I primarily think of is code duplication. And with code duplication, you think of the fact that you have your GraphQL SDL that models your type system. So I just pulled this from the GitHub public API. So we have mergeable state, and it has a few different enum members, so conflicting, mergeable, unknown, with some comments there. And then in your code base, presumably somewhere in some runtime object. Here I just have it as an array, but you could, an enum or an object, you have the same representation. So these two need to be updated together. Whenever you make a change to one, you have to remember to make a change to the other, and it's just kind of unnecessary. So the double declaration problem is really that you're oftentimes defining something in the SDL, and then you have to also define it in runtime code. The next point is with interfaces. So if you are using interfaces throughout your code, anytime that you make a change to that interface, you then have to find all of the objects that implement that interface. So for example, here from the GitHub public API, we have the uniform resource locatable interface, which I guess represents a type that can be retrieved by a URL. And if we wanted to add another property to this, we'd then have to go look through the code base. If you're developing with SDL, presumably it's kind of split up into a bunch of places and then brought together and update it in all 16 of those locations that it's used in GitHub's case, instead of just updating it once on the interface in the code and having that update the schema automatically for you. The next point is documentation and type ordering. So I think that when you're developing SDL first, at least this was my my experience, I wouldn't be as vigilant about like documenting with proper what is it, the field description. Sorry, description on the object type or any of the strings or enums. And so I think that you, when you have the code automatically generated, you can run the function in GraphQL.js that automatically sorts it for you, and you have this really nice canonical document of what the representation of your schema is, and it leads to great diffs when you're checking in the source, and you can see what sort of runtime code changes, how that affects your schema artifact. When you're building for larger teams in the same way, I think when that it becomes more difficult when you're manipulating these string types and trying to build abstractions upon that. You also have to teach this concept to a lot of people who might not be as familiar with it. And along those lines, I think that the tooling can become complex to manage this because it's not all sort of centralized. You end up with a lot of different ways to merge these things together or to add behavior. And then I think it's also sort of pushing toward this microservice idea, the fact that you should be splitting these up into independent services and stitching them together, which I don't know is necessarily something that you want to start out with. So these are some of the points of some of the shortcomings, I think, of SDL first. And now I'm going to talk about GraphQL Nexus and how this aims to take a different approach on this. So you can find the documentation at nexus.js.org. And GraphQL Nexus is Codefirst, as is the title of the talk. But it's meant to be declarative. It's meant to not necessarily, even though you're not starting with SDL first, like the string artifact, that doesn't mean you aren't developing with the schema in mind first. So you could think that the schema of this user type, which has these fields, would map pretty similarly to an object type, which defines them. You can see here that we have the name of the type and then the different fields, considerably less imports. The resolver is declared right next to the type, and it's sort of easy to read and understand what's going on here after you get familiar with the syntax. So it's not too much to learn. Type safety is the biggest thing that the GraphQL Nexus tries to do, but it also aims to be JavaScript friendly, and these two are sometimes at odds. So I'll go in a little bit more detail of like how this is working, and it's also slightly opinionated, but not too much, hopefully, and it's configurable, so hopefully it's not too controversial. But the first thing I ask when I see a new library is sort of what makes it different. Because you have a lot of buzzwords like declarative or fast or anything like that. And so I think what makes it different is the development feedback loop. And what I mean by this is that the make schema generation, the make schema function generates the types. And generating the types, sort of, you declare all the types and then import them into this function. It then generates the schema and types and outputs those as artifacts to your file system, which are then picked up if you're using TypeScript or if you're using JavaScript with like TS type checking. It then picks those up and automatically infers them into the runtime functions to make sure that your schema is type safe. And then when you make changes to the schema and restart the server, it regenerates those and sort of starts this feedback loop again. So I'll just show a quick example of what I mean by this. So this is the Star Wars application example that you can find in the root of the repository. Oh, was that running? Let me see. Oh, no. Huh. All right, well, sorry about this. Is it running? Oh, it's not running on my screen. Okay, here we go. So let's see. So these are some of the declared enums and objects that you'll find when you're defining your objects this way. And then we'll go to the query where we have a field called OK, which returns a Boolean of true. And then we'll add a string field called test and return a number. And automatically this is a type error, so because it's a string type, so we'll change this to the string one, and then it's happy with that. We'll add a new field called droid, and this is going to be like the droid type in the Star Wars API example. And so here you can see that it's automatically showing all the potential output types that you can choose from. And if we have the resolver, it's expecting an argument, so we'll go ahead and add this as args, and we'll do an ID with a string arg. And then if we add our resolver, we can see that it's automatically typed, so it knows that it's a string. And if we remove that, then it goes away. So it's, without writing your types out, it's knowing what the types are. And then we can see that this is a type error because undefined is not assignable to string. So we'll take a look at the schema and see that it is a string, but it's not a string exclamation point. It's not required. So we'll jump back here and set required to true. And from there, then you see the type error goes away. So if you looked at this file, you wouldn't know that it is TypeScript because we didn't have all these type annotations. But it's taking some sort of clever ways of merging conditionals and that I'll show in a second, and these generated types and inferring all of that for you. So type safety is a big point, and the way that it works, like I said, is you define the outputs. So you see the schema and type gen, and that's where it's going to write the files to the file system. And then in development, so when Node is started with development mode, it generates these files automatically for you to wherever you specified. And this schema that's generated is just a normal one. You can use it with any of the existing tooling that's out there, Apollo server or anything else. And how is it doing this? Well, it's using a feature in TypeScript called Conditional Types, which is kind of confusing at first. When I saw it, it was like T extends U, X, Y, like what? It's too many letters. And what this really allows you to do is to capture the way that we're using it is we're capturing the name of the type and the name of the field, and then using that to dynamically sort of map that in and say that the return value of that field is the field type of droid primary function, and then we look that up with this sort of nested conditional process that you don't need to worry about. But we're able to know whether, based on what the backing type is, what the type is that resolves to root, whether the field needs a resolver or not. So if you have like a database field or a database representation in TypeScript where the field is optional, and you have a field for that in your GraphQL, then you know that you need a resolver because it's a nullable field. So the end result of this really is just that it's type safety with less typing. So like I said, if you look here, you wouldn't know if it's JavaScript or TypeScript. And the idea is that you can have type safety with it getting out of the way. So the next piece that is pretty new that I've been working on, but I think is really powerful, is building custom type-safe abstractions. So things that are specific to your application, because everyone is using GraphQL a little bit differently. And so one common pain point that I have found is building connection types or associations between two different types where you don't want it to just be a list of return values because you want to have more data there, like the total count or the pagination info, or similar to like the relay connection spec. And the way that we're doing this with GraphQL Nexus is that we are able to define these custom fields. So we have this connection field, which defines the type definition, and we're able to customize like what the typing for that should be, and then this automatically is picked up by the library, and it leads to this, where we have this custom connection field, which is custom for Cypress, and we see that we've defined that nodes and total count are two required fields on this object. And again, it's automatically knowing what the types are of the args based on the implementation here, and knowing that the return type has to be of a certain type. So right here, the promise instances is not assignable to promise-like run group. The TypeScript errors, I think, could be a little more friendly, but hopefully they'll get there with that. But the idea is to make something that was previously really complicated. Like if you were doing this with SDL, anytime that you have a connection, you go through this process of making sure that it matches up the same way for every single field. And that takes a lot of discipline and a lot of, if you have multiple people in a company working on the same API, you'd want it to be consistent. So having these abstractions that sort of are able to build those constructs for you, I think is really useful. And then in a similar way, a new thing that's coming out is Nexus Plugins, which is the ability to add user-defined type-safe additions. So for example, adding an authorize method to the individual fields. So we could return true or false as to whether or not someone can use it and sort of have that defined on the field level. But only being able to customize that behavior and not having that shipped automatically, being able to just sort of pull these in and have it automatically add the type safety in the field type definitions and the type definitions or in the schema definitions. So another one that I think would be neat is like enforce docs. So this is overriding the description field on the type def and on the field def, so that if you don't add a description for your type, then it would be a type error, essentially. So like really enforcing internally that you want everything in the GraphQL schema to be documented, which I think is good to have in the long run. So yeah, like I said, it's just the idea of being able to augment the library behavior both at runtime and at types based on these user definitions. And a cool example of this, I'm not going to go too much into it, is Nexus Prisma. They've been doing a lot of work sort of demoing or pushing the boundaries of what Nexus can do and giving a lot of great feedback. So if you're interested, take a look at their implementation. I mentioned that the library has some opinions. One of them is on nullability. So there's this quote in the GraphQL documentation that in the GraphQL type system, every field is nullable by default. And the reasoning they give for that is that a database could go down, an asynchronous action could fail, an exception could be thrown, which is valid. But I think that exceptional states should be exceptional, and that null to indicate network failure should be declared and documented. And when you have everything nullable by default, you're sort of like punting that problem to every consumer that then has to do the null check on the field. So I think that when you're new to GraphQL and you don't realize this implication, then you end up, like I looked at the example from one of my first slides where I had the first type I ever sort of built, and I see that all of my strings were nullable, and realized that if I were actually modeling it correctly, everything probably would have been there except for maybe distance. So by default, Nexus has the fields be non-null, but this is configurable at either the type level or the schema level. So if you disagree with this, you can change that. So because a lot of schemas are already developed in SDL, built sort of a little converter to see what it would look like if you took your schema and pasted it in on the left and see like what the equivalent would be in Nexus on the right. So give that a shot if you're interested in any of this. And you can actually, if your endpoint is public, you can paste the public API there. Really quickly, I'll touch on some of the rough edges that are still to be solved. So a lot of this sounds great when it works, but there is a little bit of configuration that you have to do to get these types mapping up correctly. Because the types that are inferred for the resolve are dynamic using that conditional, then being able to jump to a concrete definition doesn't really work, and sometimes the TypeScript errors can be a little cryptic with this. I don't think it's too much of a problem, but it is a little bit of a learning curve. And again, you don't have to use this with TypeScript. You can use it with JavaScript, so there's no problem there. And also the chicken and the egg problem, it's like if the types don't exist already to make the schema run, then how do you start it to then generate the types? And so I think there's just a little bit of tooling and documentation that might be needed there. But this isn't the only project that's doing Codefirst and having the SDL be an artifact. So another one that if you're want more traditional TypeScript, where you have more type annotations, type GraphQL is great, where you sort of define a class and then annotate it with types and fields and use that metadata to generate your GraphQL server. GraphQL Compose is another one that is actually kind of similar. It's almost like if you took Nexus and turned it like inside out, and Nexus is more of a declarative approach, and GraphQL Compose is more of an imperative approach, like you're adding fields to objects and building those up that way. And I know that Gatsby uses this, and it seems like it works pretty well. So this is another one that's pretty neat to check out. So what's next for GraphQL Nexus? So like I mentioned, the dynamic methods are available. The plugins that I was showing aren't quite there yet. I have a branch and they're almost there. But another piece that's missing is programmatic directives. Although I don't think you need directives as much as you would because you have the full capacity of the runtime language to be able to write these resolvers or these plugins that do sort of similar to what directives were used for the majority. Directives are useful sometimes, like for Apollo Federation, to be able to annotate the SDL for external consumers. But it's something that is definitely doable and we'll have in there. And then also just better interop with SDL snippets, just because it is super useful still to write an SDL, particularly when you're prototyping new features, or you don't want to have the you just want to paste a bunch of extend this type with these fields if you're not sure what the implementation should be yet. And we use that at Cypress to prototype new features where we get the schema that's generated from the output of the SDL and then merge that with some of our new extensions and then generate a mock GraphQL schema for that for our testing. And it's also just the common language that we speak between all the different server implementations. So it's really useful in that regards. And I don't think that it's necessarily that you shouldn't do SDL first. It's just that if you come across some of these same issues that I was sort of questioning, this might be interesting to look into. But I'll just leave with, like, at the end of the day, users don't see the code. They just want a good experience on the web. And also internally, like, we want to build good developer tooling. And so whatever tools help you best solve problems are really what you should use. So thank you very much.